Hey everybody, homework help video here for section 24-2. This is on page 245 and 246 in your practice book. So again, section 24-2, so day 2. And yeah, page 245, I move this around, 245, 246. All right, so let's take a look here. The at least the beginning page, it starts with this example here with Mr. Nichols. It says Mr. Nichols followed the road from the entrance of a park to his campsite. So we're camping here. You can see it's shown with the dotted lines there. But it says he drives 6 miles south. Oh, so that's right here, 6 miles south, going down, and then 3 miles. Oh, whoa, 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 whoa! I need to erase that. Put that back up there. 6 miles south. Now I'm all messed up. 3 miles or 5 miles east, so 5 east, 3 south, and then 7 miles east, and ended up at the campsite. So we're going from the entrance to the campsite. And in all, how far did Mr. Nichols drive? Suppose Mr. Nichols had been able to drive straight from the entrance to the park to the campsite without having to go south and east. How could you find that distance? So it says you can use the diagram to help you solve the first problem, or at least the first part of it. Add the individual distances to find Mr. Nichols' total number of miles. And you could do it with the diagram. You could use it with the numbers. We had 6, 5, 3, and 7. So those add together, you get 21 miles total. Now that's how far he drove. Now to find this distance, if we wanted to go straight here, we'd have to use the Pythagorean Theorem. Because if we actually draw this all out, we would have, ignoring that stuff in the middle, we would have a right triangle, which, again, you can count total number of miles south and total number of miles east, and that would be, I think it was 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9 miles south, and this is 12 miles east, and you can use the Pythagorean Theorem, 9 squared plus 12 squared equals c squared, and solve it for c. And that's actually what was done. It was set up here as well in this bottom paragraph. So number 1, it says find the distance if Mr. Nichols had been able to drive straight from the entrance to the campsite. So we actually have to take that and solve it. It was set up for us, 9 squared plus 12 squared equals c squared. But we want to find what that c is to find the exact distance, because you can't just count. I want to show you that, like on a grid like this, you can't just count because they're diagonals. They're not actually straight up and down or left or right. So we're going to have to figure out using a different method, and here's the Pythagorean theorem to do that. All right. This is something that's very helpful to have a calculator with you. I've got mine with me right here. And if you recognize this is a Pythagorean triple. Pythagorean triples are those whole numbers, like a group of 3 whole numbers that work for the Pythagorean theorem. And we'll check it to make sure, but 9 squared is 81. I know 12 squared, or 12 times 12, is 144. And then that's equal to c squared. So we need to add those two together. I'm going to check that 144 plus 81. You could check it on a calculator. You could write it out. I get 225. And then what's your last step? You take the square root. So square root of c squared gets you c. Square root of 225 gets you 15. So that means that if you would have gone straight there, it would have only been 15 miles total. Whereas what he drove going south and east and south and east was 21 miles. So you could save 6 miles if you could go straight to it. I know every campground doesn't work that way, but we wanted to figure that out just in case. So number 2, how much shorter would Mr. Nichols' drive have been if he had been able to drive straight from the entrance to the campsite? Well, I kind of just explained that. If it was 21 that he drove, the difference between that and 15 is 6 miles. And I'm going to let you explain that in words. Okay? Make sure you explain. All right, let's go to the next page, number 3. You tie a spherical balloon. So that's a a 3D circle, essentially. That's at the top here. Spherical balloon, we're assuming that's our balloon. That is 2 feet in diameter. Okay, so we're assuming we can picture that the 2 feet is right here. To a stake in the ground, and the string is 15 feet. That's shown right here. The wind blows, and you observe that the top of the balloon is 8 feet away from the stake. So that's right here. So originally, if it was right above the stake, it's 8 feet away from that, as shown in the diagram. What is the height? So if the height is not going to be like 15 feet, or if you count the two more, it's 17 feet anymore, the height actually changes if it goes to the side, because the string doesn't get any longer. So if this whole side length, which I'd like to point out that we have to figure out that whole side length, because this makes a triangle. It's shown here. We have a nice right triangle. From here, goes straight to the ground, so it makes a right angle. We've got one side, that's the hypotenuse. We've got the smallest side, which is 8. And again, that hypotenuse, we'll say, is 17, because 15 plus 2 gets us 17. What we can do now is use the Pythagorean theorem. The height we don't know, and that is actually one of the legs. It's not the biggest side. So the hypotenuse is the biggest side across from the right angle. So that's the C. This can be our A, and what we're trying to find is B. So let's plug it in. So if our Pythagorean theorem, a squared plus b squared equals c squared, let's replace A. We have 8. B we don't know. And C is 17. Okay. 8 squared is 64 again. We don't know B squared. 17 squared, I do not have that one memorized. So 17 squared, or 17 times 17, I get 289. Checked it on my calculator. Now at this point, it's a little bit different from that last one. Remember, if we're trying to find the A or the B, we can't add the A and the B together because we don't know what they both are. So we're going to have to get the B squared part by itself by subtracting 64 here. Do that on both sides of the equation to keep it balanced. You get B squared equals 225. So then last step would be take the square root. That would give us B, the square root of 225. I think we did that on the last one. It's 15. So 15 feet. Make sure you show all that work, because so in this case it's 15 feet above the ground, even though technically that's all the way to the top of the balloon. Originally, where it was from the stake to the top of the balloon was 17 feet. So a little different there. Okay. Got a couple more. Let's go to number 4. Number 4, in problem 5, the wind blows harder and the top of the balloon is now 15 feet over from the stake. So let's just say we take our triangle. So our balloon is up here. It's actually 15 feet over from the stake now. This is 15 feet. But this is still, this whole thing, the rope and the balloon combined is still 17 feet. We don't know this one. It says, what is the height of the balloon now? Draw a diagram to help you solve the problem and explain the answer. Now, you might notice something about this, and I'm going to, if you notice it, awesome, explain it. Please do. Because there's a really easy way to do this, and there's also a technical way to do this. But ultimately, we want to figure out how high it is now, if it's being blown farther over there. And so, take a look. It is a right triangle because it still could make that right angle to the ground. And let's do everything we did. Now, we don't know if this is, technically we'll say this is actually A, because this looks like it's the smallest side now. It doesn't matter between A and B. What really matters is that we know that the C is still opposite of the right angle. So let's use the Pythagorean theorem. Let's say A squared plus 15 squared equals 17 squared. Okay? If you solve that, this we already had was 225. This we already actually had was 289. We had that above. We want to subtract 225 from both sides. And we end up with A squared equals 64. Oh, 64. So when you take the square root, guess what? You get A as 8. So 8 feet is how high it was. Now it does say to explain that. So explain that you can explain how we did that, but if you look at this, how does that compare to the one above? If you notice, it's the same triangle, it's just shifted or rotated because it's still an 8 and the sides are still 8, 15, and 17. It's just the A and the B kind of flipped around a little bit. So if you recognize that right away, you didn't have to show that work. You could put that explanation there as your explanation because the explanation is the biggest part there, showing that you know what you're doing. All right, last one. The perimeter of an equilateral triangle is 48 centimeters. Use estimation to find the height of the triangle to the nearest whole number. Include a sketch of your answer. So just as a reminder, equilateral means they're all the same sides. So if you take a triangle, usually it looks like something like this. They're all the same sides. So if it's 48, the perimeter is 48. There's 3 sides. You can take 48 divided by 3, and you get 16. That means each side length is 16 centimeters. But it's asking for the height. The height isn't one of the side lengths. The height is going straight from the very top straight down to the bottom, and it actually does make a right angle. It says use the estimation of the height to find the nearest whole number, include a sketch. So if you cut that, this would actually cut it in half. I know it doesn't look perfect, but this would be 8 centimeters. We don't know the height. And the other side of that, I'm just picturing one of the 2 triangles now, and it's an 8 by H by 16. And we can't, you could estimate it. It says to estimate it. I mean, my guess would be if we had, the other one was an 8 by 15 by 17. This is an 8 by something by 16, so it's probably a little bit lower than 15, like 14. So I would guess maybe 14 centimeters. But let's actually check it. So let's take this. It's a right triangle. Let's take our 2 side lengths. Let's say 8 is our A, H is our B, and 16 is our C because that's the hypotenuse. Okay, let's solve it. So 64, 16 squared, 256. Now here's where we have to subtract 64 because they're on separate sides of the equation. So to get the h squared by itself, we have to get subtract. So 256 minus 64, and I get 192. And then take the square root, and we'll get our h. So the square root of 192 is about 13 point, I'm going to round here, it's about 13.8, and rounded to the nearest whole number would be 14 centimeters. So my estimate was correct, and maybe that was your estimate too. And this is how you can show how to actually do it. So the height's about 14 centimeters tall. All of these applications that are in this homework have to do with using the Pythagorean theorem. Okay, again, a squared plus b squared equals c squared for all right triangles. And it'll always work. Right triangles are everywhere. You can take a square or a rectangle, you can cut it down the diagonal and make it into right triangles. So the Pythagorean theorem really is very useful. It is very used in a lot of different fields. All right, so there's our homework 24-2 on page 245 and 246.